Good morning, students. So, once again, I welcome you to my video lectures on control systems. And I will make a beginning with a new topic, and it is what is known as frequency response methods, also known as frequency response analysis. See, at a later stage, I will going to take up the stability analysis coming under linear control systems. Stability analysis using Nyquist criterion and stability analysis using Bode's plots. For both these methods, which are called semi-graphical methods, the knowledge of frequency response is very essential. So what I am now doing, I will take up first, I will going to develop or I will going to build up the concepts before I take up those two methods. So students are hereby required to start with what is known as frequency response methods. Frequency response method is not a new topic for you. If you are in third semester, I think, in electronics lab, you have conducted many experiments which come under frequency response methods. I will remind you few experiments. Number one, RC coupled amplifier. You have conducted experiments on RC coupled amplifier. So what you will do in RC coupled amplifier experiment? You will going to rig up the RC coupled amplifier, single stage. I assume that it is a single stage using transistor. Then you are going to connect a signal generator. After connecting the signal generator, you are going to keep the amplitude of the input signal constant, and you will going to vary the frequency over a wide range. And what you will record on the output side, still the output is a sinusoidal in nature, but shifted in phase. And you will going to record both input amplitude and output amplitude. The ratio of output amplitude to input amplitude is what is called as magnitude ratio. So this is one of the data. Still one more data is there, that is phase angle data. I will come to that later. So this is what is called as frequency response analysis experiment. I can remind you some more experiments. If you have done experiments on operational amplifiers, so frequency response of inverting amplifier, frequency response of non-inverting amplifier, etc. So essentially, here in the first case, it was RC coupled amplifier. You can also switch over to op-amp circuits and you can take up this analysis, what is known as frequency response method or frequency response analysis. It is going to serve us data. So using this data, you have to extract the data from frequency response method, and we have to develop what is known as stability concept. Stability according to Nyquist criterion, then stability according to Bode plot. So from this class onwards, first I will take few or 8 to 10 hours I will going to spend on this, and I will going to develop concepts. And the very first concept is frequency response concept. So first you understand frequency response concept, and then I will proceed further. Okay? What is frequency response method? First you go through the definition. Frequency response data refers to steady state output of linear system subjected to a sinusoidal input of constant amplitude and frequency varied over some range. First, you have to take up the system. First, assume that the system is a linear system. For example, RC coupled amplifier. It is a linear system. So you have built a linear RC coupled amplifier, which is considered as a linear system. So frequency response data refers to steady state output. I want to remind you, there are two types of outputs: transient output and steady state output. Transient output means disturbance. It has not yet settled. Steady state means the output that is going to remain for ever. That is what is known as steady state output. So you have to subject the system to a sinusoidal input of constant amplitude. Now, this is the block diagram of a linear system, and I am giving an input of A sine omega t, small a. A is amplitude, omega is angular frequency. And you have to keep this A constant. You have to keep this A constant, and you have to vary this omega over some range, over kilohertz or megahertz. Normally, while conducting the experiment in lab, we used to take a millivolt input. So A is of the order of millivolts. So A sine omega t is the input, and omega is varied. If you turn the knob of signal generator, then omega is varied. And while varying the omega, you should see that, because in RC coupled amplifier, the biasing should be perfect. It should operate in the middle of the load line, because otherwise, if it is not in the middle of the load line, then what happens? You will going to get a distorted output. That is not correct. So you should see that output is still a sine wave. So input is a sine wave, output is also a sine wave. So input is this, A sine omega t. And the smaller one I have shown is output, that is B sine omega t plus or minus phi. That means the output in this diagram is, this may lead the input out waveform, or this may lag behind the input waveform. That is why plus stands for leading waveform, minus stands for lagging. Whereas in this figure, I have shown output lagging behind input by an angle phi. Now, you have to record the output. So, one column A is constant, no doubt. A is constant. Throughout the experiment, A remains constant. B is going to be varied, is it not? B is going to be varied. So you have to vary the frequency over a wide range, and you have to record the values of B. So what you will do? You will employ a CRO on this side, and you will record B. After recording B for a certain value of A, then you have to form what is known as frequency response data. There are two important data. Number one, magnitude data. So magnitude data is m omega, function of omega, because as omega varies, m also varies. What is m omega? M omega is B by A, the ratio of output amplitude to input amplitude, B by A. So this is what is called as magnitude data. And another data, normally you will not going to record this, even using CRO. You can record phi. So phi is what is called as phase angle data. Y is what is called as phase angle data. You can also measure phi using CRO. But normally we teachers will not instruct the student to record phi omega. Normally we ask you to record m omega data. So phi omega is what is called as phase angle data. So these two data are very important in what is called as frequency response method or frequency response analysis. So after recording a B value over a range, and after forming magnitude data and phase angle data, you can make use of these two data to investigate stability of control system. So that comes in Nyquist criterion as well as in Bode's plots. So in this class, I have explained what is frequency response method and what are the good examples of frequency response analysis experiments, and then what is frequency response data, what is frequency response method, and what is frequency response data. So with this, I will conclude this class, and in the next class, I will continue further. Thank you.